Okay, so welcome to section 2.4, which is reference angles. Okay, so definition, what is a reference angle? So for any non-quadrantal, meaning not on an axis, quadrantal, angle theta, the corresponding reference angle, so the corresponding, which is what we're defining, reference angle, let's call it theta sub r for reference, is the measure, or is its measure, from the x-axis. From the x-axis. And that's either above or below the x-axis. Okay, so this is best shown by example. So for example, so determine the reference angles for the following. So determine the reference angles for the following. Okay, so number one, let's do theta is 45, I don't like that equal sign, is equal to 45 degrees. Number two, let's have alpha is 120 degrees. Number three, let's have beta is equal to, what shall we do? 225 degrees. And number four, let's have phi is going to be 330 degrees. That sounds good. Okay, so let's go ahead and draw our x and y coordinate axes. So x and y, and let's color code these. So theta is 45 degrees. Okay, so we can draw that right here. It's the main diagonal, not drawn very well. Let me draw this a bit better. So this is 45 degrees. So what is the distance to the x-axis? Well, it's 45 degrees. So I claim that theta sub r, reference angle, for 45 degrees is also 45 degrees. Now let's plot alpha is 120 degrees. So that's going to be somewhere here in quadrant 2, 120 degrees. But that's only 30 away from 90, so this must be 60 degrees to the x-axis. So now alpha reference angle is 60 degrees, because that's how far away alpha is from the x-axis. Okay, so beta, let's have beta, 225. Well, what's interesting about 225 is it's 45 degrees away from the x-axis. So notice that beta reference is the same as theta reference angle, but they're in two different quadrants. But they're both the same distance away from the x-axis. Okay, last but not least, what color should I use? Let's use blue. Phi is 330 degrees. So that's in quadrant 4. 330 degrees. And that's only 30 degrees away from full circle. So phi reference is 30 degrees, because that's how far it is away from the x-axis. So notice we can think of having your arms out along the x-axis and going up and down, waving your hands. And you're measuring the distance that you're going. Okay, so let's recall. Recall. And I'm going to use the symbols we know from our symbol sheet. So for all theta such that the absolute value of theta is strictly greater than 360 degrees, this implies that there exists an integer k, or k, an element of the integers, such that theta can be written as phi plus or minus 360 degrees times k. Okay, so let's translate a bit of this. So we know that upside down A means for all. The backwards C with a line through it and a colon, that means such that. So for all theta such that the absolute value of theta is greater than 360 degrees. Okay, so the double right arrow, it's a terrible double right arrow. The double right arrow, this implies the backwards capital E means there exists K, and the forward C with a line through it means in or slash an element of Z, which is a 7 and an upside down 7, capital Z, is the integers. Once again, we have such that theta is equal to phi plus or minus 360 times k. Okay, so what I'm going to do is translate the following. K is an element of the integers. We can translate as any integer k. Okay, so what do I mean by this? For example, oops, that's a terrible example. So for example, let's find the reference angles for the following. So find the reference angles. Reference angles for the following. So number one, let's have theta be 490 degrees. Okay, so I see that theta, actually let me do this in purple. So theta is greater than 360 degrees. Okay, well that means I can write theta as some angle phi plus 360 at least once. So the difference between 490 and 360 is 130. So I claim that this is 130 degrees plus 360 degrees times 1. So my k in this instance is 1. That's the integer that I'm multiplying 360 by. And my angle phi that is between 0 and 360 is 130. So let's go ahead and draw 130 degrees, which is after 90 and before 180, so I know it's in quadrant 2. And in fact, why do I need my axis to be so large? Doesn't need to be, I can put it up here. Okay. Okay, so I'm in quadrant 2 at 130 degrees, which is not quite the diagonal. So here's 130 degrees. So how far away from 180 is that going to be? I claim that's 50 degrees away from 180. So I claim that the reference angle for theta, which is also the reference angle for phi, is 50 degrees. Oh, I forgot to label my axes. Shame on me. X and Y. Okay, so let's do another one. Let's do theta is equal to 1300, shall we? 1300 degrees. Okay, well, it should be clear that theta is much larger than 360. Okay, so that means I can write theta is some angle phi between 0 and 360 plus an integer multiple of 360. Okay, well, 3 times 360 is 1080. And if I'm at 1080, then I'm 20 degrees away from 1100, which is 200 degrees. So I claim that that's 220 degrees plus 360 degrees times the integer 3. So my k in this instance is 3. The phi is going to be 220 degrees. So I can plot 220, which is beyond 180, but not quite 270. So I know I'm in quadrant 3, X and Y. So 220. How far away from 180 is that? 220 to 180, that's 40, right? So I claim this is 40 degrees here. So my reference angle, theta reference, theta sub r, how far away from the x-axis am I? 40 degrees. Okay, let's do another one. Hopefully this is making sense so far. So subscript number 3. My spacing was pretty bad for this. Maybe I can bring these problems down just a bit so it's not so cramped up here. Does that look a bit better? Okay, so now number 3. Let's have theta be, what shall we do? Negative 390, something like that. Okay, so now in absolute value, theta is larger than 360. But let's think about this. I'm going to have to add, if I were to add 360, I would still be at a negative 30. So it looks like I'm going to have to add 360 degrees times 2. So I'm going to have to add 720. So what's the difference between, how do I get, if I add 720, what will I get? Well, 720 minus 390. Is that what I'm going for? Let's do that off to the side. 720 degrees minus 390 degrees. 0 minus 0 is 0. 12 minus 9 is 3. And 6 minus 3 is 330. So I claim that our phi is 330 degrees. Oops, and that's minus. That's a minus because we're going negative there. So my integer is 2. My phi, which is between 0 and 360, is 330. So now let's go ahead and plot phi so we can find the reference angle. That looks like it's in quadrant 4. So x and y coordinate axes. So I'm in quadrant 4 at 330. 330 degrees, which is how far away from 360? Well, it's 30 degrees away from 360 and the x-axis. So theta sub r is 30 degrees. That's my reference angle for theta and for phi. Okay, so let's recall. Let's look at the SIG ends in each quadrant. So x and y coordinate axes, how much space do I have? Okay, so let's go ahead and draw x and y. Hopefully, okay, good enough. So x and y. So if I had a point in quadrant 1, x comma y, that point would have signs positive comma positive. And so we say all trig functions positive. So all trig functions positive in quadrant 1. Okay, if I'm in quadrant 2, if I have a point x comma y in quadrant 2, the x coordinate is negative, but the y coordinate is positive. So this would be sine is positive, because sine is y over r. So now let's go to quadrant 3. If I have a point x comma y in quadrant 3, well, I know both are negative. So the quotient, tangent, which is y over x, will be positive. So tangent is positive in this quadrant. And last but not least, in quadrant 4, x comma y, well, now the x coordinate is positive, but the y coordinate is negative, so this has that cosine is positive. And for those of you guys that enjoy acronyms, I'm not one of them, but I know some people like them. So for those of you that like them, here it is. All students take calculus. It's not that great. Okay. So let's note. I'm not a fan of acronyms, but it might help you. And if it does, then by all means. So let's note. So sine is greater than 0 in which two quadrants? Well, sine is y over r. So the y coordinate is positive in quadrants 1 and quadrant 2. Cosine is greater than 0. Well, cosine corresponds to the x over r, so it looks like the x coordinate is positive in quadrants 1 and quadrants 4. Okay. So remember, sine of an angle theta was y over r, whereas cosine of an angle theta was x over r. So let's see what that means with respect to x and y coordinates. So let's quickly do a little x and y coordinate axes. X and y. I don't know why I can never seem to. I have such an aversion to to even numbers that I can't seem to ever do this right to where it will be perfectly even. Maybe one day. So here's x and y. So I know that sine is greater than 0 in quadrants 1 and 2. No. What am I saying? Yes, it is. Yes, the y-axis, right? Whereas cosine is greater than 0 when x is larger than 0. Agreed? So up the y-axis and up the x-axis, if that kind of helps. Anyways, it's a mnemonic device. If you care to use it, that's fine. If not, don't worry. Okay, so let's see. I've got space. So what I'm going to do with my space here is I'm going to recall this very important chart. And we're going to go through it because these numbers are so important. So I'm going to list theta. And I want 0. Let's see. 1, 2, 3, 4, 5. I might be able to do it. Let's see, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90. I believe I did it. Okay, good. I have enough room. That's always good. Okay, so I'm going to list the 6 trigonometric functions. So let's first do darker blue. Let's do sine of theta. Wow, can't draw a straight line to save my life. Thank goodness for autocorrect. Okay, so let's see. So sine of 0 degrees was 0 over r, or 0. Sine of 30 degrees was 1/2. Sine of 45 degrees was the square root of 2 over 2. Sine of 60 degrees was the square root of 3 over 2. And sine of 90 degrees was 1. Don't worry, you don't have to have that memorized just yet, but it would be nice. The sooner, the better, trust me. Okay, so now let's do cosine of theta. Cosine is the x-coordinate over the radius. So cosine of 0 is 1. Cosine of 30 degrees is the square root of 3 over 2. Cosine of 45 degrees is the square root of 2 over 2. Cosine of 60 degrees is 1/2, and cosine of 90 degrees is 0. Now let's do the quotient, tangent. So tangent of theta, 0 over 1 is 0. 1/2 divided by root 3 over 2. The 2's reduced, and I'm left with 1 over root 3. Then 1, anything divided by himself. This next one reduces to root 3, and then thou shalt not divide by 0. So tangent of 90 degrees does not exist. Now let's do the reciprocal functions. So let's see. That's too dark. Let's do this one. So cosecant of theta is the reciprocal to sine. 1 over 0 does not exist. 1 over 1/2 is 2. Flipping this root 2 over 2 upside down and rationalizing gives me root 2. Then we have 2 over root 3. I don't care if you rationalize, that's fine. And then 1 over 1 is 1. Okay. Now let's take the reciprocal to cosine, which is going to be secant. Ugh, that's such a terrible color, isn't it? Sorry about the bad color scheme. Okay, 1 over 1 is 1. Then we'll have 2 over the square root of 3. The reciprocal to root 2 over 2 rationalizes to root 2. Reciprocal to 1/2 is 2. And thou shalt not divide by 0. So the reciprocal to 0 does not exist. And last but not least, let's go ahead and do, I'll have to do this one, cotangent. The reciprocal to tangent, 1 over 0, does not exist. Then we'll have root 3. If I flip that upside down, 1. Then I'll have 1 over root 3. Then it looks like I'll have 0. So it looks like cotangent just went backwards. What tangent did. Okay. But wait, there's more. Let's also recall what the triangles look like. So if I had a 30, 60, 90 right triangle, so this small angle here was 30 degrees. Oh, that's a terrible 30. Why can I not draw? This large angle here will be 60 degrees. Okay. Okay. So we know that the ratios are 1 to the square root of 3 to 2 in a 30, 60, 90 right triangle. What else do we know in a 45, 45, 90 right triangle? So 45 degrees, 45 degrees. That the sides are in a ratio of 1 to the square root of 2. So this is 1 to the square root of 2. Side to hypotenuse. Okay, so let's note. So the trigonometric value of any angle, so the trigonometric meaning sine, cosine, tangent, all of that. So the trigonometric value, trigonometric value what is wrong with me? Value of any angle is equivalent in absolute value. So is equivalent in absolute value, meaning save for a plus or minus in absolute value, to that of its reference angle. So to that of its reference angle. That is i.e. So we can evaluate the trigonometric functions at the reference angle. So we can evaluate, and of course I'll do an example in a moment. So we can evaluate the trigonometric functions. Metric functions. At theta sub r, and then tack on plus or minus with respect to WRT, the quadrant in which theta lies. Okay, so what do we mean by this? Let's do an example. So for example, so use reference angles to evaluate sine, cosine, and tangent of the following. So use reference angles. Reference angles to evaluate sine, cosine, and tangent of the following. Okay, so number 1. Let's say we have that theta is, 405 degrees. Okay, so let's go ahead and look at theta like we did above. Well, I claim that 405 is larger than 360. So I claim that I can write theta as some reference angle phi plus 360. So what is the difference, 405 to 360? Well, I claim that that's 45 degrees. So 45 plus 360 degrees times 1, right? It's 1 revolution farther. So the phi that I want to plot is 45 degrees. So let's go ahead and plot that phi, which is in quadrant 1. So x and y. So I claim that this 45 degrees is actually the same as 405 degrees. And the reference angle, of course, is 45 because we're in quadrant 1. So this is pretty straightforward. So theta sub r, actually let me move this up a bit so I have more room. So theta sub r is 45 degrees. Okay. So what I claim is that sine of theta, or 405 degrees, is going to be equivalent to, so equivalent has 3. That's going to be equivalent to, I'm in quadrant 1, so sine, the y-coordinate is positive. And then this will be sine of the reference angle, 45 degrees. Okay, so I can then go back to my chart. Sine of 45 degrees, root 2 over 2. So this is positive root 2 over 2. Okay, I claim that cosine, what color should I use for cosine? Maybe green. So cosine of 405 degrees, I claim that that's equivalent 3 to cosine in quadrant 1 is positive, to positive cosine of the reference angle, 45 degrees. Okay, so cosine of 45, well, cosine of 45 is root 2 over 2. That's root 2 over 2. And I claim that tangent, what color should I use? Blue. Tangent of 405 degrees is going to be equivalent to the quotient of the two guys above them. So this is equivalent to tangent of 45 degrees. And if I just take the quotient of the two above, anything divided by himself is 1. Okay, well this didn't really illustrate much, so let's kick it up a notch with number 2. Let's have theta being, I don't know, negative 420 degrees. So now once again in absolute value, theta is larger than 360. So I claim that theta can be written as, well, it's negative 420, so I have to add 360. That's not enough. That'll still be negative. I have to add another 360. So I claim that 720 minus, so it's 300. Okay. So this will be 300 plus or minus 360 times 2, right? It was 720. So my reference angle, phi, is 300 degrees. So let's go ahead and plot that reference angle. Or no, that's not my reference angle just yet. That's the angle between 0 and 360. We're going to find the reference angle once I plot phi. So let me not get ahead of myself. So 330 degrees, that's in quadrant 4. So x and y. So 330 should be over here. So this is, oops, oh my goodness, what's going on? Sorry, that's not 330, it's 300. What am I saying? Let me do this correctly. 300 is down here. So this is 300 degrees, which is equivalent to negative 420. But what I'm most concerned with is the reference angle. It's 60 degrees away from 360. So my reference angle, theta sub reference, is 60 degrees. Now I can actually illustrate what I was trying to up here. So I claim that sine of negative 420 degrees is going to be equivalent to, well, sine in quadrant 4 is negative, right? So if sine is negative, the y-coordinate is negative in quadrant 4. I'll have to tack on a negative sign here. Well, I claim that this is equivalent to negative sine of the reference angle 60. Okay, well, that's going to be negative of, what is sine of 60 degrees again? Sine of 60 is root 3 over 2. Okay, so that's going to be negative root 3 over 2. And of course, let's show that this is because B/C, because in quadrant 4. Right? Okay. Now let's do the same thing for cosine. So cosine of negative 420 degrees. Well, cosine is the x-coordinate over the radius. So that's going to be positive, because I'm in quadrant 4. So that's going to be positive cosine of the reference angle, 60. Okay. Cosine of 60. Well, let's go back and see. Cosine of 60 degrees is 1/2. Okay. So it's 1/2, positive 1/2. Tangent, however, of negative 420 is just the quotient of the two above. So this should be equivalent to, well, a negative divided by a positive is a negative. So this will be equivalent to negative tangent of 60 degrees. So what does that give us? That'll give us negative. I have root 3, so it looks like I'm just going to have root 3 because the 2's reduce. Okay. Let's do one more for good measure. And I don't have enough room, do I? Why does this always happen? I never plan my pages well. So number 3. Let's have phi being equal to, that's a terrible phi. Phi being equal to 600 degrees, which is clearly larger than. So phi in absolute value is greater than 360. So I claim that my angle phi can be written as some angle, let's call it alpha this time. What shall it be? So 360 and 360 is 720. So it's actually just going to be, what's the difference between 360 and 600? Well, what's that, 240? 240 degrees plus 360 degrees times 1, right? So now I'm going to plot angle alpha equal to 240 degrees. And then we'll find the reference angle. So I claim that that is in quadrant 3. Because it's not quite 270. Oops. But it's larger than 180. So x and y coordinate axes. I'm at 240, which is going to be, what, 60 degrees away from 180? So here's 240, which is equivalent to 600 degrees. Okay, so how far away from 180 was that? It's 60 degrees. Well, is this going to be the same as the answer above? I don't know. So phi reference is 60 degrees. Okay, so let's look at this. Sine of 600 degrees well, this is going to be equivalent to, I'm in quadrant 3. Well, both sine and cosine are negative in quadrant 3. So this is going to be equivalent to sine, negative sine of 60 degrees. That's my reference angle. Okay, so that's just going to be negative of, well, didn't I just do this? And wasn't sine of 60 degrees something like root 3 over, what's going on? Root 3 over 2? So I claim that this will be negative root 3 over 2. And once again, this negative is because b over c, b slash c, in quadrant 3. Similarly, cosine of 600 degrees is going to be equivalent to negative cosine of the reference angle 60. And that's going to be negative, what was cosine of 60 again? Wasn't it like 1/2? Okay. So once again, let's annotate. This is also because the negative were in quadrant 3, so both y and x are negative in quadrant 3. And last but not least, let's go ahead and evaluate tangent of 600. Well, all students take calculus. So we have a t is positive in quadrant 3, and that t corresponded to tangent. So this is just going to be positive tangent of the reference angle, 60 degrees. And I can simply just take the quotient of the two guys above that. The 2 is reduced, and I'm just left with root 3. Okay, there we are. Hopefully this makes sense, and I'll see you guys in the next section.